Salam, our chapter today is about antiderivative. Yesterday we started the first part, definition of antiderivative. We said that capital F of x, antiderivative and antiderivative of small f of x. It's not the antiderivative. The function have infinity of antiderivatives. If and only if capital F prime of x equals small f of x. To show that this is the antiderivative of the small f of x, you only have to calculate its derivative. We did explain this yesterday, and we gave some examples about it. Also yesterday we started the integrals, rules of integration, how to find the antiderivative of a certain function. Of course, we said that the antiderivative is symbolic by integral. The symbol that represents the antiderivative is integral, which is like a long s, a tall s. Okay, like derivative is represented by prime. You know, the derivative of f is f prime. The antiderivative of f is the integral of f. And you also add dx. Dx is just to explain who is the variable. So if the function is the variable if t, you should write dt. If the variable is s, you should write ds. So dx is her role here is just only to determine who is the variable. Let's just we wrote yesterday these rules: antiderivative of x power n. You add 1 to the exponent, then you divide by it. You always have to add a constant c. Antiderivative of k is kx plus c. Antiderivative of 1 over x squared is minus 1 over x plus c. And antiderivative of 1 over radical x is 2 radical x plus c. For example, if you have the antiderivative of x power 5 plus 5x power 4 minus 3x squared minus 6x minus 1 plus 1 over x squared minus 2. And you need to calculate its antiderivative. If you have plus or minus between the terms, you can calculate the antiderivative of each term by each side. So you can calculate antiderivative of x power 5. You only have to add 1 to the exponent, is x power 6 over 6. For example, x power 4, you only have to add 1 to the numerator, to the exponent, so it's x power 6. X power 5 over 5. X power 2, you only have to add 1 to the exponent, is x power 3. Then you divide by the exponent. X is x power 1 and it's 6x power 2 over 2. 1 over x squared is a rule. Antiderivative of 1 over x squared is minus 1 over x. Antiderivative of any constant k is 2x plus c. Then you can simplify if you like to. For example, 5 with 5, you obtain x power 5. 3 with 3, you obtain x power 3. 6 with 2, you obtain 3x squared minus 1 over x minus 2x plus c. So yesterday we said that if you have plus or minuses between the terms, you can find the antiderivative for each one. But what if you have multiplication? What if you have division? What you are going to do? So first example is going to be if I have 2x into x squared plus 5 power 3 dx. Okay, we have a product between two factors, so we can calculate the antiderivative of the first factor times antiderivative of the second factor. Also, we have a power, so when you have a power of a certain factor, you can simply calculate the antiderivative of its factor. Here we are going to use variable changing. Variable changing, it means that you change one of the variables. Yeah, you change not one of the variables. There is only one variable. You change the variable. You take let u equal the factor, the biggest factor, you name it as u. Let u equal x squared plus 5. Then you have to find du. Du is the derivative of u. Derivative of x squared plus 5, derivative of x squared is 2x, derivative of 5 is 0 dx. Okay, so when you have a product or divide between factors, you have to use maybe variable changing, maybe another method that we will learn later. But till now, if you have a product between two factors, you should use let u. So here I'm gonna write the formulas that are using when you are using let u chain rule. First formula is as the same: antiderivative of u power n du is u power n plus 1 over n plus 1 plus a constant c. Same formula, but with the letter u. So when you say let u equal x squared plus 5, du is going to be 2x dx. In this case, for example, this term is going to be u. So it's u power 3. 2x dx is du. So you change the variable. Now the variable is u, and you have u power 3. According to this rule, the antiderivative is u power 4 over 4 plus a constant c. According to this formula, the antiderivative is u power 4 over 4 plus a constant c, where u in this case is x squared plus 5 power 4 over 4 plus c. And that's how I did find the antiderivative of this function, even though there is the multiplication between the terms. Another example about this. Another example, antiderivative of 3x squared plus 1 into x cubed plus x plus 5 power 7 dx. We have a product between two factors. We also have a factor who has a power, so we can't calculate the antiderivative of each one. So you should use, in this case now, I'm going to use let u. Let u equal the biggest factor. The biggest factor here is x cubed plus x plus 5. When you take let u, you should take it without the powers, without the power of this factor, and if there is a radical, without the radical of the factor. You just take what is inside the factor. du, some of the teacher write it as u prime. Du is here in the derivative of u. Derivative of x cubed is a 3x squared. Derivative of x is 1, and you add dx. So the factor is going to be, the integral is going to be, this factor is u power 7. 3x squared plus 1 dx is du according to this identity. According to the first formula, first rule, it's u power 7 plus 1, 8 over 8 plus a constant c. You should replace u by its value. So it's x cubed plus x plus 5 by its value in terms of x over 8 plus a constant c. This is the first formula. The second formula is the same as this one. Antiderivative of 1 over u squared du is minus 1 over u plus c. And the last formula is going to be the same as this one. Antiderivative of 1 over radical u du is 2 radical u plus c. So we have the same formulas, but with the letter u when we do a variable changing. Let's give some other examples. For example, antiderivative of x plus 1 power 5. Let's give a simple example, dx. You have a factor with a power, you can't calculate its derivative, so you have to say let u. Let u is equal the biggest factor. Here there is no other than x plus 1. So du, derivative of x is 1, derivative of 1 is 0 dx. So du equal dx. This integral is going to be u power 5, 1 dx, or dx is du. Antiderivative of u power 5 according to the first formula is u power 6 over 6 plus a constant c. Another example, antiderivative of 2x plus 3 over radical of x squared plus 3x plus 1 dx. Let u equal the biggest factor, and in this case u is what's inside the radical, so it's x squared plus 3x plus 1. Du, its derivative is 2x plus 3. So this integral is going to be 2x plus 3. You should always add dx. 2x plus 3 dx is du. Radical x squared plus 3x plus 1, it's radical u. According to this rule, antiderivative of du over radical u, it's 2 radical u plus c. So it's going to be 2 radical x squared plus 3x plus 1 plus c. I think it's enough for today. We should repeat the same work again, maybe tomorrow. plus some other examples and maybe an application. See you.